Thanks. Oh, we get an intro. Awesome.
Oh, brief one, yes. Jordan, that sounded really, really loud. So just so you know that we just can start. Welcome to today's Durham School sponsored Lunch and Learn, which is co-sponsored with the Carbon Leadership Forum Hub of Nebraska. I am very pleased to have these two speakers today talking about embodied carbon around timber, concrete, construction site emissions. I know Stuart Shell quite well. He's from BranchPattern, and I hope you'll do a little more, because actually I saw that I did not get a bio from both of you, so I apologize that I did not prepare well so I hope you will do a brief introduction. But Stuart is a graduate of our architectural engineering master's degree, and has gone on to do lots of great stuff at BranchPattern. And I was pleased to meet you today, Paulina. Get your last name in here too, Paulina Gonzalez Pichardo from Kiewit. Our school is an umbrella of architectural engineering construction, so it thrills me to have the two of you making this presentation together to cover both of those areas. So please give them a warm welcome.
Thank you, Dr. Long. It's an honor to be here. I'm really excited to talk to you about things we see emerging on the landscape for construction and new metrics that are becoming more important, not just cost and performance, but ecological impact. So I'm Stuart and have a background in design. I started as an architect and got an engineering degree here, and have continued to focus on the research side of our work as we work with our customers that are trying to understand and reduce their impact in the world at BranchPattern. And Paulina, do you want to give a quick intro? I'm so excited to present with you today.
Thank you. Yeah, Paulina Gonzalez Pichardo. I am originally from Germany. No, right? My accent doesn't sound like German. I am originally from Mexico City, and I am the corporate sustainability manager at Kiewit. My background is industrial engineering with a master's degree in environment and resource management from Amsterdam, the Netherlands. And then working experience has to do with working manufacturing plants as environmental coordinator in plants in Mexico. And then coming to the US, started working for Kiewit for 4.5 years now. And I'm so excited to be able to share with you my experience, knowledge in relation to greenhouse gas emissions.
Thank you. Paulina is going to get us started, but I wanted to share a couple slides about Carbon Leadership Forum and give you a little more information about the organization. This is a local group that has meetings, so opportunities for you to engage if you're interested in this topic. We'd love to have your help. We are one of the hubs of a national effort, actually really international effort. The Carbon Leadership Forum has roots at the University of Washington, so it came out of the academic space and has more recently become its own nonprofit and has a decentralized model for impact throughout the nation by sponsoring and aligning with hubs like ours. So we share resources, but they really have a ground up approach to change, which is inspiring to be part of. I feel like it's an organization that understands the social dimension, the social challenge of changing the way we make buildings. That it's not just a technical issue, it's one of the motivation and political will for change also. They provide a lot of great resources, and one of their focus areas is policy, recognizing that laws drive a lot of the change that we've seen in the construction industry. A lot of us are familiar with energy codes and how that's driven building performance over the last 20 years. We're seeing more codes emerge around emissions from construction activity, both during construction, but also once the building's in operation. And they are at the forefront of helping to draft those laws and helping communities adopt them, like Nebraska. If you want to support any state legislation, a lot of that's called Buy Clean. with the idea of reducing pollution that's caused by construction materials. So that's an intro. Today we're talking about two sides of this challenge. I'm excited to talk about some of the technical components that comes down to materials and how we use them. And I'll also talk about some of those trends I was just mentioning. And you're gonna get what, in my mind, it might be a more important view also, in terms of what's driving this change from the perspective of organizations that have set goals or maybe even experience mandates to reduce their emissions. And frankly, that's who hires companies like mine. And so we don't get to do our work unless it's being driven and motivated by corporate initiatives. So I'll pass the baton there to you.
I'm going to time myself. I want to make sure I don't get to steal time here. Okay, so let's start with a common question: why? Why is tracking greenhouse gas emissions important, or why is it happening? Well, as humans, we need to reduce our adverse environmental impact to the environment, right? So we need to account, okay, we're already having an impact. How much is that impact? How big is it, or how small? What is not measured, we know it cannot be improved. We know that we need currently to comply with regulations. As some of you might already know, we have regulations in Europe and some here in the US, Canada, and other countries that requires us to disclose greenhouse gas emissions. An example of that is the SB 253 from CARB, California. In 2026, we will need to disclose greenhouse gas emissions as Kiewit as a company, but also other organizations. Why is this? Well, you guys, newer generations, are asking how companies are treating their employees, the impacts in the society and in the environment. How are you doing as an organization? How are you supporting us as human beings? Our clients are asking for that information. What is your impact? How much waste do you produce? How much energy do you consume? What are your greenhouse gas emissions? And a lot of public companies are required to disclose this information also through frameworks of the SEC. So these are our drivers. Before I start with this big picture, and I know Stu is going to be going more technical, deeper into the information. So for the ones that might be listening to this topic as new, when we're talking about greenhouse gas emissions, they are connected directly to energy sources. So we get the data from energy sources, and then we convert that data into the total emissions that we have as an organization. The first step to get this information is, let's understand, for an organization focused on construction, let's understand how many facilities we have, including offices, how many projects do we have, or that we want to include, where are they located? Do we want to account for all the projects in 1 year? As a construction organization, a lot of the times, we're not only talking about projects or offices, we're also talking about quarries that construction companies own, asphalt plants, batch plants. Do we want to include them in our boundary of greenhouse gas emissions, or should we just focus on our specific projects? For this presentation, we're only going to discuss, or my presentation, we're only going to talk about the construction project site emissions, not including emissions from offices or other specifics. So I like questions. So at the end of the presentation, we will be able to answer some of your questions, and I hope you have a lot, because I love the interaction. But now I'm going to start asking you guys a question. What are the sources of energy during the construction phase of a project? Any idea?
Making light fixtures.
Making like fixtures. Yeah, that would be from a manufacturing plant. Yeah, okay. Diesel. Fuel from equipment.
The emission of carbon during the hydration process of the cement.
Oh, I like that one. Okay, yes, emissions of carbon while we process concrete. Okay. Here is a list. So fuel from the equipment. The fuel is using, sorry, the equipment is using fuel, right, to operate. Natural gas or propane. We have trailers supporting the project site or offices for that specific project, right? And that they need heating, right? Whether it's propane or natural gas. Electricity, right? If we're connected to the grid, are we having some renewable energy out there? I decided to put here in the last refrigerants. So refrigerants are not a source of energy, but they do affect or actually emit greenhouse gas emissions, so that you know about it. But Paulina, where do I find these numbers? Question for the audience. Where do we get the number of gallons, kilowatts hours, gigajoules? Tell me. Excuse me?
The engineering management.
Engineering management? Anyone else?
Electricity is going to be on the electric bill.
Yes, in the invoices, right? That's one of other options. So invoices, right? There are some systems in place that organizations have where they actually track this data in the system. For instance, ERPs, SAP, Oracle, if you've heard of those. Utilities websites, whether it's not a physical invoice, but actual website that you can read the measurement. Submitters on site. Is somebody actually going and reading on a frequency basis, hey, this is the amount of electricity that we're consuming. So it seems to be relatively easy. We already said, hey, these are the projects that we're going to account for greenhouse gas emissions. These are the energy sources. This is where I'm going to get the data, invoices, or whatnot. And doesn't that sound easy? I mean, let's just do that. But when we're talking about projects, are we talking about just the one project? How many projects do construction companies have in a given year? 300? And you guys know that projects can go as short as 1, 2, 3 days to 10 years. And they're moving, right? Today I have a project here. Tomorrow I have it in Canada. And then I have another team in Mexico. How do I manage and align? So challenges, every project is different because every project has its own scope. We need to understand what technology out there is available, for how long do we have to track information in the projects. People are rotating. Let's say about systems in place. Does the company already have a standard procedure to say, in all the projects, we will have this job position, assign this task to track fuel consumption? And if not, how do you communicate that? How do you standardize it? Where are they going to track this information? would I be able to actually track the amount of fuel in each piece of equipment? Wouldn't that be nice? How many gallons am I consuming per each piece of equipment? My advice is to piggyback from the systems that we have already in place. I wanted to share here what technology is out there to capture this data. These are the names of some platforms in the market that help gather the data, analyze it, and then come up with the greenhouse gas emissions calculations. Persephone, MVC, etc. Okay, could we just track from smart meters instead of having somebody take actual physical reading, or instead of having somebody having to enter the data in the system if it directly connects to a Persephone? Hey, is there any software, hardware that I can connect to the equipment that can actually tell me how much fuel we went through? Truefill and UrgeNet. So UrgeNet is this one system, website, that gathers the data from different utility companies and can give you the report for the companies that you want. So if I have 100 projects, I make sure that they are all providing me with the access of the utility companies, and then I can download actual data from that report. Instead of having a person printing or getting, filing the invoice, tracking it in SAP or in Excel so that it gets paid. I'm not going to go into detail on how to calculate greenhouse gas emissions, but wanted to make the connection of white energy with that energy consumption, or whether it's gallons of fuel, gigajoules, kilowatts hours. Then there is this greenhouse gas protocol, which is very well used, that guides us on how to calculate greenhouse gas emissions. And there are databases that we use to convert these emissions, or sorry, these energy numbers into greenhouse gas emissions. Here to mention some is the TCR, the DEFRA, the EGRI from EPA. They are not the only ones. I'm just sharing an example. Challenges for reducing fuel consumption. We're talking about the data tracking. How do we track the data? How do we standardize processes? We need to make people aware about how, in our operations, we are emitting greenhouse gases, right? How do we train them? What policies do we have in place to reduce those greenhouse gas emissions? And within the next slides, I'll share with you some of the practices we have in Kiewit to help support the effort. The problem of working in remote sites is something I will also talk very fast on. But if we are trying to go to electrification of my construction fleet, and I am working in a remote site, how do I actually am able to use that electric fleet if I cannot even connect to the grid? Those are challenges. So finally, I just want to showcase Kiewit's actions in relation to greenhouse gas emissions. So since 2009, we have prepared our greenhouse gas emissions inventory. We already have it third-party verified, which means we get audited on how we're calculating these emissions, right? What is the methodology we use? What assumptions we're considering in this? Not surprisingly, our main source of scope 1 emissions, which is our direct emissions as a company, is the fuel consumption, specifically diesel. So we are working very closely with manufacturers so that we can try pilot projects to see if with the new technology that they are putting in their equipment, we can reduce fuel consumption. I was talking some about how can we reduce fuel consumption, specifically challenges. Are there policies in place in the organization? We do have a policy, the anti-idling policy. So it tells us that we should not idle for more than 5 minutes. This helps us reduce fuel consumption, noise for the community, right? Costs, and greenhouse gas emissions. When we're talking about what other things related directly to fuel are you doing to reduce your adverse environmental impact? Okay, we're looking on ways that we can use renewable diesel, biodiesel, right? So that the use of them is affecting the environment less. We're adding battery electric vehicles and energy storage systems where possible, as I mentioned. If it's possible, we'll do it, depending on where we are talking about. We have this machine control technology that tells us how frequent we need to give preventive maintenance to the equipment so that it continues to be efficient and we reduce fuel consumption too. So something I want to point out and last comment is in relation to our data analytics. I was telling you, wouldn't it be great that we can capture the fuel consumption per piece of equipment? I mean, I think that's amazing. Well, we have telematics for years as a company, since 2014. Does anybody know what telematics is? So it's hardware and software that we installed in pieces of equipment, and it gives us different data of the equipment. An example of that would be, hey, how much fuel did the equipment use? How many hours did it run? When was the last time I changed oil? If people are putting their seatbelt for safety reasons, etc. And then we capture the data and we can follow up accordingly or play with the data, do the analysis. And then finally, very fast, just wanted to share with you that we are electrifying our fleet. One of the challenges is we cannot just go from day to night to electrifying our fleet because, first of all, there's not a lot of construction equipment already developed, manufactured that is electric. We will need to connect to a grid, and we currently work in remote areas. Think about the time it takes to charge an electric equipment in construction. Would we need to wait for the operation to happen because that equipment is charging? Imagine the delay on the schedule. So those are things to consider when we're talking about electrifying our fleet. Thank you.
No, we have until 1:15, but yeah, it's great if we can.
Okay.
Yeah. The 1 o'clock is a good time.
Okay, great. If I summarize what I want to share today, it would be that we need engineers to help us move beyond energy to address emissions, which is technically kind of complex, but it means getting beyond just the part we control, understanding the systems we're a part of, like what this map is, where energy is produced, how energy is produced. The other thing is I think we need engineers to reach out more to our counterparts, like in the corporate world, where we're starting to see the accounting practices incorporate emissions impacts, but also to ecologists and environmental science, because carbon isn't enough. And in fact, if we focus on carbon only, we might be making bad choices from an endpoint analysis. So I'll say that again at the end, but that's what I'm hoping to share with you today. And this just shows the gray dots. That's where we're still using coal. I think the blue dots are natural gas, which is what we're trying to shift our fossil production towards. And then nuclear, we're working on micro reactors and small modular reactors. So those are exciting things for engineers. The challenge with energy is when we can have it from these sources. And this is part of what we need help solving from a storage perspective. And buildings don't just take now, buildings also give. They're sources for energy production. We put renewables on buildings, especially solar. But we also are putting back, electric batteries, battery energy storage systems, and thermal energy storage in buildings too. And those are interactive. They can be dispatched remotely. And increasingly, I think we'll see utility companies providing those incentives to gain access to those private resources to improve grid resilience. And so this is what I mean by engineers needing to go beyond just the energy component. Net zero isn't meaningful from an energy perspective because the energy you get back to the grid may be different in quality than the energy you take from the grid, depending on when, right? The time of use matters a lot. And let's see, did I jump? Yeah, so this is just to let you know that we have predictions on what will happen too. And this is scenario planning, which engineers increasingly, I think we're designing assets for at least a couple decades, hopefully more. So our assumptions should be based on some reasonable scenarios. NREL provides the scenario viewer for electricity grid, which projects what emissions will be like. And so when we're making decisions about the emissions impact of, say, putting a heat recovery chiller in versus geothermal water-to-water heat, we make these technical decisions. Looking at the current state of the grid for what the ecological impacts isn't going to be predictive enough, or it's going to be potentially very wrong in terms of your estimates. And then this is just a little bit of additional context about why I think carbon is not sufficient, because we really have a broader landscape that we're trying to optimize around the ecological impact and sustainability in buildings. And you've probably seen these United Nations goals. These are at least a couple decades old now, but they still remain relevant, and buildings impact many of these categories that are, again, these are things to consider when doing any development work. So that's infrastructure, that's also buildings. I want to talk just a second about energy because in my career, energy has been the focus. And I spent a lot of time optimizing enclosure systems, getting rid of thermal bridges, passive design, and then optimizing systems. We've all heard the reduced loads, then optimized, then renewable, We've learned all about energy, but we have a ton of it. And in some ways, I think energy use is correlated with quality of life. We don't need to necessarily be afraid of energy. It's an abstract thing. And this is just to let you know that there's a science here that we need to begin engaging with. And that's what I mean by connecting engineers reaching into the environmental world and this science of life cycle assessment, where we are directly impacting these midpoints, which are all these little items. Global warming potential is one of them. So the Carbon Leadership Forum is currently pretty focused on that, but CLF brings this approach, right? When you study the emissions impacts, you're actually dipping into this literature, which is very rich in terms of our ability to also address water quality, toxins for humans, and these other endpoints that actually are what we care about. And so not getting hung up on energy or carbon per se, but how are they ultimately related to quality of life? And the complicated science of scenario and Bayesian inferences and things necessary to connect those. When we talk about CO2, we talk about the whole life of a building, and we're talking, the carbon leadership forum is really focused on the upfront emissions because they happen right now, and there's direct market signals we make with direct emissions. So there's an urgency that's not as compelling as operational emissions because those are predictions we're making about what will happen. This is what emissions might look like for a typical building today, where that big spike up front is that first emissions. That's pollution caused by all of the processes to get a building in place. We say embodied carbon. The carbon, it's not embodied in the material. Some people would call that like embedded carbon, or in the case of wood or stone, we might call that biogenic carbon. But embodied carbon is actually referring more to all the activities it took to get that thing where it is. So like the mining and extraction equipment, the construction site equipment, all of these activities is what you create an inventory of when you study the embodied carbon of the material. And we have goals that are pretty clear. The AR6 report updated it to know how much our budget is. So it's not like we're just trying to reduce to be good stewards. It's that we're actually trying to stay within an allotment that there's been global agreements around, right? We've made commitments as a society, as a nation, to our nationally determined contributions. And the Science Based Targets Initiative has made this really simple for you. They've already, buildings cut across many sectors in our economy. And the United States, budget for emissions up through 2050 is split up by those sectors. There's not a building sector. But Science Based Targets is just recently, last year, they did the hard math of figuring out what would, if you just looked at buildings across those sectors, what would the budget be for different types? So those different colored lines are different types of buildings. And if you look at a different country, the chart changes also based on what that country's nationally determined contributions are to the budget. So where you do a project matters for how much emissions you're permitted, and what type of building is actually an important factor too. And this is very knowable information, even though none of us are currently really using it. It's becoming more knowable with all the legislation we're seeing. And this is just a little bit of this is a bit outdated now, but this is a graphic that shows, California leading the way. Europe has been requiring the CSRD for at least 5 years now, which first targeted operational performance for buildings, but now has also started to tackle these other upfront components.
Kiewit, what's CSRD?
Corporate Sustainability Reporting Directive, I think. Thank you for that task. That's a cross-cutting measure. Again, most of the legislation is aimed, there's a lot of states that have taken the initiative, like California a long time ago, probably at least 5 years ago, committed to buy clean for its own state facilities. But only recently, I think 2 years ago, through Cal Green, did they make that a requirement for all construction projects, that they meet the buy clean thresholds for concrete, steel, insulation, and glass. So yeah, that point was, let's get smarter about our emissions, because while it's complex, because of the dynamics of time, like year over year, we're designing assets, and the dynamics of our grid seasonally and even daily, right? Those are all variables in this equation that engineers have a direct influence on. So if you just look at energy, you're missing the importance of those ecological impacts. But engineers are well positioned, especially at the building level, to tackle this. I'd say maybe even more so than folks that are managing those systems, you know, the utility providers and the district energy managers, they have to deal with the loads that are coming from the buildings, whereas the engineers can help manage that. So just get into a little bit of detail. Concrete. Concrete's the largest source of construction emissions currently. And concrete's a composite material, right? And it's pretty hyper-local. The batching plants that mix up concrete and send it to the site are normally within 15, 20 miles of the project. But that doesn't mean that all the ingredients to the concrete are hyper-local. Cement is the most significant contributor to pollution in concrete, and you can see it's a fairly small portion of the actual mass of the finished mix, right? But as the binder, it's the most important part also. This is just a map of emissions from cement production. I think this is emissions. It might be it might be amount of product produced, but the Global Energy Monitor does this for a lot of industrial processes, and they just recently did this for cement manufacturing. So this is a new resource we've got, again, just to give us insight. So you can think of this as sort of, these are the people who are paying the cost of our concrete use, because there's an equity and social justice component to this also. It's not just carbon that's emitted from the production. Clinker is what you use to make cement. You grind up the clinker. To get clinker, you have to melt limestone. When you melt the limestone, it produces a lot of emissions, and it takes a lot of heat, which typically produces a lot of emissions too. So even if you electrify somehow the cement production, you still are having a huge amount of emissions just because you have to melt limestone in order to create the hydrolysis of that reaction. So just one side note is it's not the only binder in town. We do have, especially for exterior, for outdoors, we use flexible pavings a lot. And these have a much lower embodied carbon. I'm realizing I put in a GIF, that's kind of fun. But you don't have to design rigid pavings. And this is probably one of the easiest ways where you can switch out of concrete. That's a smart choice. We'll talk about timber next as one of the key options that you have as a replacement for concrete in structural design.
You feel like taking questions?
Yeah.
But in the last slide, it occurred to me, does a flexible pavement have a drawback that it requires more power to the car to drive across it because of more friction?
Maybe. Yeah, but you know, they take that into account in the LCA studies.
Okay.
So they talk a lot about vehicle lane miles and stuff like that. When they talk about the use phase of a product, they include the differences in performance during the use of that lane and mile of highway or whatever. So yeah, there's a rich literature here for us to draw on. And I don't think we can become experts in this, but we need to find our experts and help support that emerging industry so that we have more consultants capable of helping us bridge to this science of ecological impact. So we have a lot of options for other binders. A lot of these are a little bit unfortunate replacements like fly ash. We get fly ash from coal plants. So creating a strong secondary market for fly ash probably hasn't been the best thing. Similarly, slag comes from blast furnaces for steel production. So again, we're creating a secondary market for a byproduct from something that has a pretty negative impact also. Steel is one of the largest, after concrete, emitters in the construction process. I think you even get slag when you recycle steel, like in an electric arc furnace. So that's probably the best way. You've heard about green steel, comes from mostly recycling these mini mills, which use electric arc. But you can also use pozzolans, which can be natural. You can basically grind up volcanic rock, and that has a pretty effective use as a binder, not as a complete replacement. Similarly, just glass, you can finally grind glass, and it can replace some portion of the cement, maybe 10, 15%. Sublime Systems is working on the chemistry of creating a cement that performs the same as ordinary Portland, but is done with electricity and water somehow, hydrolysis. So there's a lot of investment and innovation in that space. So those are things to keep an eye out for in the space of concrete. I think high-level summary there is concrete's the starting place for reducing construction emissions, and finding alternatives is the best way. We don't have a way of abating concrete production that's ready to scale. It's still in pilot phase. So timber's exciting, and we love talking about it from an embodied carbon perspective. There's a lot of momentum. I want to temper your excitement a little bit. And this is what I'm point about going a little bit beyond the carbon and not feeling like that. Again, carbon is kind of what we consider a midpoint outcome in a life cycle perspective. And it's not necessarily the end point that ultimately matters. But mass timber is the type of construction that we're seeing grow. Half of construction is already wood. It's residential and it's light frame, and it's pretty efficient. Generally, light frame wood construction is, panelized systems with ribs that are studs and plywood. It's a very good way to build. Mass timber is probably a little less efficient structurally, but it can accomplish larger spans and do things that we want, like fire resistance for our commercial construction. So that's why there's an allure. It's also beautiful if you can, to the extent you can leave it exposed in structures. There's almost always a topping of that, so you're really not walking on it, but the underside of cross-laminated timber is often exposed in these buildings. There's a lot of, building codes that now are broadly accepted mass timber, so we're seeing a lot more uptake. The forests that we use, so initially it was really a European product, so we were importing it because there were no factories here making cross-laminated timber, or mass ply is another type of mass timber. It's just like super plywood sheets. But I'd say we are spinning up our industry in this regard. There's been some bumps along the way. The large wood startup went bankrupt, forgetting their name right now, out in the West Coast a while back. But anyway, we might think of our forest as the Pacific Northwest. Actually, most of our wood's coming from the Southeast, and that's loblolly pine, and it's from plantation planting for the most part, which you can think of like rows of pines, you can think of all the same age trees, and then you can think of clear cutting for that production. And largely that's displacing other types of forests. So you could call it a forest, in the jargon, you'd call it timberland or managed timberland. It doesn't mean it's necessarily being harvested, but that it's in that space. So it's an interesting world. I've been trying to learn a lot more about it, but the World Resource Institute has an excellent report that I think is a nice counterbalance to a lot of the marketing you're hearing from the American Wood Council and Woodworks Inc., which are industry associations set up to be green for us and make it look like it's our way out of a problem. When we increase wood production, we're creating competition for ecosystems, and we're creating land use change. The forests that produce wood are not of the same quality and do not create the same ecosystem services as the forests that are managed as forests, not as timberland. And again, there's a rich science here. Most of the carbon's in the soil. And currently our definition of sustainable forestry just is that you're not depleting over time the amount of carbon that's stored in that system. I think that's probably a fairly limited indicator to use whether or not your forestry practices are sustainable. But because in the United States, the carbon stored in forests has continued to increase over the last decade, the industry makes the case that, well, this wood is being sustainably harvested. So you can see on the left there is what a forest in the southeast would look like from a carbon perspective in terms of what's stored in the soil and what's stored in the actual the tree structure. And then on the right is more what you're seeing from a harvesting cycle. Normally it's every 20 or 25 years. And yeah, so what exactly is happening there? I'm not quite educated enough to be able to tell you, other than I want to communicate that even if this is a carbon no-brainer, it may not be the right choice for us to be increasing the rate of change of land use to plantation plans in the southeast. These are biodiverse regions, so I've got quite a few maps. I think that's maybe an undercurrent in this presentation. Paying attention to the geography of our impacts matters more than ever, and especially as we start to tackle biodiversity. Where you build changes the impacts that your building will have, and so therefore it should change your design concept. There's an emerging market for this, driven in part by the requirements for corporate sustainability. So this is just, I'm excited. This is Bloom Labs. They're tracking biodiversity credits. We've had a carbon trading market for a long time. That's voluntary in the United States. It's more regulated in the EU. But I think this bodes well, even though there's a lot of concern amongst environmentalists about the gamesmanship of commodifying things like biodiversity in a market and trading them. There's also great potential because our economy is the way we've achieved so much as a society. I feel like it is our most valuable resource also for creating more intelligent decisions as an industry when it comes to construction. So getting familiar with what these credits mean and trying to be a steward of intelligent use of them and maybe vetting so that we don't have some of the problems we've seen in the renewable energy market with RECs, in the carbon market with carbon offsets. This is a chance to do better in terms of creating financial instruments that really lead to the change that we want to see. Thank you.
Thank you very much. We can take questions now. Yeah, we have until 1:15, and yes, and if anybody in online or in Kiewit Hall want to ask questions, then in Kiewit Hall, I might need somebody to go up to the podium to unmute, but we can start this room first.
I was quite amazed by your plot that showed the spike in carbon emissions associated with construction and then the operating carbon emissions over the years. That challenged what I had always thought, but without a lot of data adjusted that. Oh, you used that one, yeah. And I see that you're replacing, say, HVAC systems, and you're 15 and you're 30. But so this challenges what I always thought, because I always thought the operating emissions from particularly HVAC, but also lighting and stuff, was more significant than what was embodied in construction. So I guess I'm kind of wondering, am I interpreting this correctly? And if we stacked up all those other ones, is it going to be still high? Like if we stacked up all the standard performance building stuff?
Be like the operation versus embodied.
Right.
About half and half.
And can I add on to that question? Because I guess I would have thought the curve, instead of going down, would have gone up. As things get older and don't work as well, I expected the efficiency of those systems to not be as good, and they would actually perform worse. So I expected it to go up over time. So can you, that was my question, can you talk about?
Yeah, and the rest of my question was, where did the data come from?
Oh, this is just representational. This isn't an actual project, but I would say this looks pretty close to the studies that we do. And it's premised in part on the assumptions around the electrification of the renewable energies in our grid.
I see.
So we're not using less energy, but our energy is cleaner. That's why you're seeing the smaller bars, the blue bars, decreasing over time. And as that, I think that's the intent of those pie charts. It's showing that while embodied carbon currently is maybe half of your construction emissions that you'll see over a 20-year period, in 10 years, it's going to look like a bigger piece because our energy supply continues to get cleaner. We're not putting combustion in buildings now. We're doing all electric buildings. So it basically transfers more and more of the pollution that buildings cause to their upfront phase because we're getting much better at operating clean buildings.
But even when we start to electrify, we're still burning coal to make electricity right now, especially in the Midwest. So
Yeah,
how is that better?
Well, we're assuming we're gonna do that less and less, right? That's why it's going down.
Yeah, year one, it's still bad, but year two, it's much better. And I think a lot of this depends, like, if you look at NREL scenarios for our grid, the Southwest Power Pool, and then you look at the scenarios that like NPPD has or OPPD, they don't match up. And so I think it is important to investigate which scenario we're using and maybe even talk to your customer about it. Let them have some agency in terms of how bullish they want to be about what the future might hold. They do this already for business, anytime they're making an investment. So when they invest in a building, they can also think, what is our liability for pollution going to be? It's very real in New York, where building owners now pay a penalty every year for exceeding their emission budget.
Thank you, Jim. I was too slow and I didn't notice the pie chart.
I didn't
at the
either.
top. So
Yeah,
now I-
sorry.
Yep. So you've got a high performance building that is much more embodied and standard performance building where most of it is the operation building. Yeah, that makes sense. Thank you.
So Stuart, I really thought you were going to tell us that mass timber was the answer. You said kind of the opposite. So what's the answer? What am I supposed to do?
Well,
I
timber,
can't have concrete and I can't have steel and I can't have timber.
I think wood is actually a great substitute. It's very low carbon, but don't count biogenic carbon. That's a mistake that a lot of us are still making in this space. We're taking credit for carbon that the tree absorbed when it grew and then it's stored. And that's just disingenuous. And anybody who practices LCA from a science perspective would never subtract off your petrol emissions from your biogenic emissions. They're very different. They're not the same midpoint analysis. They can't be added and subtracted together like the wood industry would like us to. The wood industry has guidelines that tell you to do what I just said. So even that said, even without counting biogenic, steel or wood construction is still better than steel and concrete. So it is a great substitute. I think it's important to ask, where is your wood coming from? Is it coming from Europe? That might actually, while it sounds stupid, that might actually be better than if it's coming from the United States, where we have much more lax regulations around forestry. The amount of pesticides that they use to maintain those plantation loblolly pines and lines, is what they say in the industry. It's kind of staggering,
And is the European forest also already logged over and over again, whereas there is still an old growth forest in the US, or is that not really a consideration?
I don't know.
I like Stu, how you kind of talked about the other impacts that, beyond greenhouse gas emissions, because that's something I think I agree it's overlooked, right? There's so many other impacts we have on the planet besides just the carbon emissions. If we focus on that itself, what are the other things that we're missing, right? Like you mentioned, we just focus, well, if we can grow as much wood as possible, it'd be great, but now we're adding pesticides and other things to the environment that could have other unintended consequences. And so I think I appreciate your kind of broad perspective.
Wood is also not recyclable. It's only, you can only downcycle it. And it's difficult to reuse. Like it's easier to reuse metal panels from a siding or roofing project, take them off and use them, than it is to reuse like wood last siding. Like give that a shot, it's like no way. So it's just, because it's a natural material, it's more fragile, and we want to start thinking of our buildings, like when you design a building, you're adding it to our store of built environment. And I think as designers, we are sort of increasingly like stewards of all the buildings. And we want to make buildings from the ones we currently have. Just like the clothing industry is trying to do that, they're trying to figure out how can we take back your clothes and make new clothes from the old ones. We're trying to do that with buildings, realizing, oh, it means we need to make clothes without harmful chemicals in them, because we don't want those harmful chemicals coming back into our new clothes. So we need to do the same thing with buildings. We should start putting the conduit like on the surface of things so it's easy to remove. Stop using drywall.
Never, would deviate to that, let me do that.
What's that?
Putting conduit on the outside of a wall.
Yeah.
Yeah,
For this
no.
purpose, yeah.
Up there is different.
We should make conduit more beautiful.
I mean, they've actually already started that by coloring it. So you can get all different kind of colors now. Absolutely. Standard products, colored conduits.
See, the architects will be okay. Say, hey, love that.
Well, probably you have mass timber, you really have to be careful because you can't hide it, right? So all the stuff gets exposed, right? So you aren't conscious about the design and where it goes. So it's just a different level of care, right? When it's hidden, you don't care.
Right.
But if you're gonna see it everywhere, then now you're all of a sudden care. Now you're gonna pay close attention to where it goes, how it goes, stuff like that. So
That's not just my like harebrained idea. That the Living Building Challenge emphasizes that. And projects like the Bullet Center, they don't bury any utilities. Everything's surface mounted. Because that's going to need to change before other things. So if you have to demolish walls and ceilings just to change out your lights, and it's like we're making bad choices. That's what I mean by acting as stewards of the built environment. Design things so that they can be disassembled.
Thank you for unmuting the Kiewit hall room. I was just gonna give an opportunity for anybody in our Lincoln location to ask a question before. Yes. I think you're live, so go ahead and ask.
How do companies like Kiewit and other companies like balance their sustainabilities in terms of operational cost and considerations, and also how do companies can measure the impact of greenhouse gas effects?
Sorry, I was not able to understand.
The audio was a little bit difficult, but I think I understood that you were asking how Kiewit, like a company like Kiewit can, was it measure? Was that right?
Yeah, balance their sustainabilities in terms of operational cost and consideration.
In terms of operational cost and direction.
Like, how do you decide how much to spend on it every year?
How do you decide how much to spend on sustainability? Oh, yes, yeah, tracking this embodied carbon.
Yes, so specifically for Kiewit, right now, and we have our sustainability report. If anybody's interested in reading that, you can go read. We have shared that we are in the path of actually understanding our consumption. So the first step is, as I mentioned in the presentation, understand where we stand. And once we have the good graph and say, hey, I already expanded my boundary to put refrigerants and job trailers and things that in the beginning were not included. Once we have that, then we can start talking about, let's start putting the dollars together to that. We already have dollars there. As I mentioned, some of the examples is electrified fleet, we already have telematics. So we're already implementing things And not only because of sustainability, right? I mean, it's not because, oh, now people are asking. It's really because that's the way we try to do business, being efficient. Now, putting the dollars amount, we're already putting it not necessarily as standardized as we want. On the other hand, we're measuring ourselves on greenhouse gases, and then we're trying to match them together to then come up with a number. But we're already doing things that we're investing money to reduce our greenhouse gas emissions. Some of that, for instance, is in an office, Lenexa office here in Kansas. We already invested in solar panels. So we have already budget for that, and for EVs, and for power to boxes that help our batteries that help reduce fuel consumption. And our standard for new buildings, that they have a energy efficient monitoring. So we have the money there. We are also trying to match it with the current numbers that we have.
Perhaps we can get a link to that sustainability report and share it out.
I love it, yeah.
With people who are registered for this. Sure. Okay. It is 1:15, so we're going to call it to a close. So thank you all very much. Thanks everybody. Keep it all. Thank you those who here. Thank you to our